Hello, Mr. Larry, Mr. Ryan. How are you today?
Good thing.
Okay. Okay. So we want to talk about longest prefix. So what's a prefix?
We know that.
What's prefix? Like
It's
word
The opposite of prefix is suffix.
with a suffix. So prefix. Can you tell me how many prefixes are there in each word?
5.
Okay. What are those?
W, 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 R, W, L.
O-I-L and W-O-I-L-D. Yeah.
The whole word.
Yeah. So there. If this length is 5, there are 5 prefix, and the suffix is D, L-D, I-L-D, O-I-L-D, W-O-I-L-D. Right? Okay. So now, given a list of the
We're going to do prefix,
Yeah.
suffix.
Okay, so today we're going to talk about the longest prefix. Longest common prefix. Or LCP, okay? LCP. Longest common prefix. So given a list of words like one, word, words, and what? Wonder. And
I wonder.
okay, so what's the longest common prefix?
W.
WO, right? Because WON is not, right? And we want to check,
When you were just saying it,
yeah?
I hear they begin with a W, so I don't need to start from W. I can start on the next letter.
Yeah, WO. Okay, so what's any thoughts how we tackle this problem? How are we going to solve this problem?
Yeah.
How are we going to solve this problem? What does it mean? What does it mean? How are we solving this problem? Eric, any idea how we solving this problem? Ryan, how are we solving this problem?
So,
Yeah.
this letter is the same as this letter is the same as this letter.
Yeah, and then we check the next one, right?
Then
Check the third one, okay?
this one,
Uh-huh.
this one,
This one is not the same. Look, N and R is not the same. Then we
this
do,
one,
yeah.
and this one. They're all the same. Just checking.
Okay, so your approach is checking characters by characters, am I right? Until we found out there's a mismatch. Yeah? Ryan?
Yeah.
So how many characters are we need to checking? How many characters do we need to check?
All of them.
All of them? Are you sure? Look, this is the shortest one. Do we need to check 4?
3.
Yeah, the minimum, right? Because there's no point to check 4 characters. The first one only has 3 characters. So, the first of all, we need to check the shortest, to get the shortest, right?
Yeah.
Ryan. And then we go through these characters by character.
Kung Fu.
Okay, that's it. So let's implement this algorithm, okay?
Kung Fu. Yeah.
Okay. Define longest common
longest common prefix.
word.
Words.
This word is a list of string, right? List of string.
Yeah.
So at the beginning, what we need to do is to find out the shortest one.
Person.
Yeah, the shortest shortest length of all the strings in the list, right? And right, look. So let's say the shortest length is k, and k, let's say, is equals to the very big number with max to infinity. And for w in what?
Words.
In words. And k equals what?
K equals.
We want to update the shortest one, right?
Yeah.
So what's the mean, right?
Yeah.
And k of what? What's the length of the word?
Words.
Length of w.
Words.
Yeah? Alright?
Yeah.
Okay, so look, these 3 lines we can turn into one line, which is k equals mean of length word, and what should we do? For
W in words.
Well done. Okay, so that's just one line. Okay. This is one line, okay? I don't have space here. So k equals infinity, the very, very big number. And I try to iterate all the string in the words And then for each string of words, I want to get the length of each word, and then update to k. K. After that, k will be equal to 3, yeah, for the 1, yeah? Got it? And then now what should we do next? What should we do next?
We shall.
We should do what? Let's say I equals 0. Let's look. Let's start.
C equals set.
Wait, not yet. One the word. Okay, so let's say we have three strings. So I at the beginning points to the first character, which is I equals 0. And then if all these are the same, it's all the same, then we point to the next one. We want to check, oh, it's the same. N and R is not the same. Then we break, then we return the first 2 letters, right?
W.
Yeah, okay. So now I start from the first one, and Y.
Excuses me.
Okay. Y what?
While K.
I
K.
Y what K?
I is smaller than K.
Yeah, because the K is the minimum, which is 3, yeah? There's no point to checking beyond the K's character, right? Color. And now look, if we want to find out if all the characters at index I is the same, we can use the set. Which is set? Set is the data structure, only stores unique numbers, unique characters, yeah? If you put 2 Ryans in a set, there's only 1 Ryan.
That's me!
If you put a Ryan and Eric in a set, there will be 2 elements, Eric and Ryan. If you put 100 Erics and 100 Ryans in a set, what happens? You will only have 1 Ryan and 1 Eric, because the set is kind of hash table, a notebook, but only stores the unique elements. So why are we? So our idea is that to put all the characters at index I for words in the set, right? And if
C is the set.
Yeah, if there's only 1 element in the set, what does it mean? What does it mean? If there's only 1 element in a set, what does it mean?
It means that's the prefix.
That's the character is and the position is all set. If it's more than 1, what does it mean? What does it mean? N and R, what does it mean? Then there will be N and R, yeah?
Yeah.
And then what does it mean? It means It
means you break.
Yeah, you break it because we found more than 1.
And then you do your previous prefix, which is WO.
Well done. I know what you mean, yeah? Okay, C equals set. Now what? WI, because we want to get the I's index, the character at index I. And then for what?
For W in words.
Well done. For W in words, okay. So this is the same as C equals set. Then for W in words, C dot add WI, okay? You can turn into 3 lines like this, but we're using 1 line, okay? Then if length C not equals 1, then
break.
Yeah, because we now found more than 1 character, not all the prefix.
I plus equals 1.
Yeah, then we check the next character. And the last, the I, we will break at I equals 2, right? So we want to get the character up to I equals 2. So return
Words.
any words, because any words, let's say we can return the first one, 0.
0 column I.
And then column I, well done. Because I is 2, and then we want to return all the characters up to 2, so which is W. And you can pick any of them. For convenience, we can put word I. Word 0 is this first one, right? Yeah? Word 0 is WON. And then if we want to column I, which is we return WO, alright? Yeah. Alright?
Yeah.
What's this part? Let's do it. What's this part of complexity? This complexity. If there are n numbers of words in strings in a word, what's this part complexity?
I-N.
Where down? This is O1, yeah. This
Me
is
got no head.
Eric, Ryan, Eric, look. And Okay.
We got no head.
Come on. Listen, the last part.
We got.
And what's the time complexity if for this part? This bit, check the k times, right?
Yeah.
Then what's this complexity? Oh what?
Okay.
Okay, we're done. Okay. Okay. And because we need to check k characters, and then for this one, for this one, we need to iterate n string, right? So actually it's OK times n because we need to check the k strings, yeah, n strings, right?
Yeah.
Okay.
Yeah, I'm making it again.
Okay. In OKN, so the overall time complexity is ON plus k times n. Okay. What's the space complexity?
One.
We are using a set here. Come on.
O-N.
O-N, yeah, because this is n, right? The n and
Yeah.
in the worst case.
Baby.
In the worst case, each character will be different, right? Maybe they're totally different, like A, B, C, D, E, F, right? G, H, I, and then the set will contain 3 letters A, D, and G. So this is the set, and then the space complexity is O-N. Okay, and then we are getting that thingy, right?
Never give up.
Okay, then let's say, what's here? What's here? What's here? While. While, come on. While I and K. While what?
While I smaller than K.
Well done. That's it for today. Good job. Right?
Bye.
Bye.
Make a bing bing in my panties.
Okay, that's it for today.